Hello, my name is Aaron Fay and I teach science at Highland Park High School. This is a reverse classroom, a short videotaped lecture about harmonic motion, which might be the next topic that you're learning about in your class. As I give this lecture, can I make a suggestion that you copy down notes as if you were in class? So write down everything that was on the screen, maybe quick sketches of the examples I give. Let's get started. Harmonic motion. Haven't I seen this before? It's actually kind of a joke that hopefully you're going to catch on fairly quick. The focus today is we want to be able to identify harmonic motion and some ways to quantify the different characteristics, and probably by using a pendulum. So the first definition is harmonic motion, and this is any phenomena that repeats itself. Now you see it all over the place, but don't realize that we use the words harmonic motion. For example, dance steps or patterns in music, if you notice, music repeats itself over and over and over again. Clocks are another example. How many times is this clock going to show the exact same pattern again? If you can identify every 12 hours, you understand that that's harmonic. A cycle. This is the smallest unit that actually ends up repeating itself. The thing returns back to the original state from where it starts. The period is represented with this T with joutes on the top of it. And it's the amount of time it takes for one cycle before it repeats itself. This is a time measurement, and so in our physics class we most commonly use seconds in order to represent period. You don't have to, though. You can use days or hours or weeks, even years, if you would like. A pendulum is a device with a free-swinging mass upon which gravity pulls down upon it. So think swings at the playground, or grandfather clocks, or even wrecking balls could be thought of as a pendulum. To oscillate is the process of swinging or wiggling in a harmonic motion, is known as to oscillate or an oscillation. Amplitude is the measurement from how far away from the perpendicular, that's straight up and down, a pendulum is set, usually on a push. Now, you can measure amplitude in distance, but most of the time in pendulums, you're talking about angles. And so you measure it in degrees. And then frequency, this very scripty F, so we can distinguish frequency from forces. It's the number of cycles that occur in a unit amount of time. So normally I would go to my physics class 5 times in 1 week. Or you have one birthday every year. And you'll notice that in frequency you have the number of cycles followed by the units of time. So for example, 8 glasses of water in 1 day. In science class, we can measure frequency in a unit called hertz. And by definition, a hertz is 1 occurrence in 1 second. If something happens twice in 1 second, we'd say 2 hertz. And 6 times in 1 second, we'd say 6 hertz. Now, period and frequency, they are related. And let's kind of review. Period is the number of seconds it takes for one cycle, and frequency is the number of cycles in 1 second. These two characteristics are inverses of each other. So period is 1 over frequency, or you could say frequency is 1 over period. Let's practice this really quick. So let's say in our class we found a pendulum took 2.67 seconds to make one oscillation. What is the frequency? So in order to solve this, I'm going to use my very standard guess technique. And guess stands for I'm going to identify the givens first. And so in my question I'm told that 2.67 seconds. So let's see, that's a period. I'm really not given anything else in the problem, so I'm going to move on to the second element of guess, and that's the unknown. What's the question asking for? What is the frequency? So frequency is question mark, and I'm going to measure it in hertz. GUE stands for equation. And I know that frequency equals 1 over the period. GUE, substitute and solve. So now I'm going to replace numbers for letters. I don't know what the script EF is for frequency, so I'm going to write it again. Equals 1 over 2.67. And when I do the math, 0.37453, which is a ridiculous numbers to record off your calculator, but we're going to fix that in a minute. So frequency is in the units hertz, and I can tell by looking here at my unknown. So I'm almost done. Now the last kind of like I can clean it up and apply significant figures. And if I look here, I have 3 sig figs, so I'm going to respond with 3 significant figures. So when I do, I get 0.37. Those are significant. The 4 is significant, but the 5 isn't, but it's going to round it up. 3.75 hertz. Well done.